No episódio de hoje do Fundcast, temos a honra de receber o Professor Harry Poulos, uma verdadeira lenda na engenharia geotécnica. Com mais de 50 anos de contribuições significativas, incluindo projetos icônicos como o Burj Khalifa, Professor Poulos compartilha suas experiências e reflexões sobre os desafios e avanços na área de fundações de grandes edifícios. Conversamos sobre suas colaborações no Brasil, a importância de combinar pesquisa com prática profissional e o papel dos engenheiros na evolução do setor. É uma conversa inspiradora sobre a trajetória e o legado de um dos maiores nomes da geotecnia. Seja bem-vindo a mais um episódio do Fundcast.
Welcome to a very special episode of Fundcast. Today, we have the immense pleasure of hosting one of the most influential figures in geotechnical engineering, Professor Harry Poulos. Professor Poulos is a pioneer in our field with over 5 decades of groundbreaking research, numerous awards and contributions that have shaped the very foundations of modern geotechnics. Having him here with us in person is an absolute honor. It's not every day that we get to sit down and have a conversation with someone whose work we've studied and admired for years. Many of us have read his papers, cited his theories, and applied his methods in our projects. Today, we have the chance to go beyond the papers and hear directly from the man behind so many innovations. Professor Poulos, it's a truly privilege to have you here. We know you have traveled a long way, all the way from Australia to be here with us in Camaçari and Balneário Camboriú, and we are thrilled to hear your thoughts on several topics from your experience also here in our city. Sure. And your reflection on your incredible career. So, welcome to Fundcast.
Well, thank you, and it's really my pleasure to be here, and I greatly appreciate the fact that I've been invited to participate in this superb conference and in this superb location. So it's my pleasure.
Thank you. So I will bring some topics that we can discuss. And
yes.
So first one that we mentioned is that what are your impressions of Balneário Camboriú so far? That you have mentioned that you were quite impressed and comment that it's very different from what you knew from Brazil from your previous visits. Could you share a bit more of that?
Yes, well, I guess before my contacts with you, I was unaware of the city. After my contacts, you told me a little bit about the city and 150,000 population and so on. But what I've really been amazed with is the number of tall buildings and the fact that in a city of this size, it looks like a minor version of some of the great seaside cities in the world, Miami, even in Australia, the Gold Coast. And it really is a fantastic place. And I think the other thing that has impressed me is that it's a very warm and friendly and safe city. And of course, that for tourists is a very big plus. So it's been an absolute pleasure to come and experience this city in person.
Very happy to hear it, and our city is. I'm pretty sure it's way different from the most parts of Brazil, and we are proud to have built this place and continues trying to live here in a place that also, as we have those challenges of tall buildings and this, I'm very happy and feel very lucky actually to be from here and have the opportunity to create our company. And
yes.
So, how do you feel about having a stronger connection with Brazil now that you are involved in such an iconic project here like the Senate Tower?
Well, I've over the years of my career, I've forged friendships with a number of people in Brazil. I've had a little bit of technical involvement with 1 or 2 projects, but this really is my first significant interaction with people in this country, and particularly I think in an area where I've spent the last 30 or 40 years sort of making it essentially my favorite topic, tall building foundations. So it's really a great pleasure to be here and an honor. And I think the Center Tower is going to really make people appreciate this city, and I think it will be in many ways a draw card for this city. It's a major structure on the world scene, and I've seen some of the plans, and if I was a billionaire, I'd be very interested in buying it, but not an apartment, a small apartment, but it is really going to provide magnificent accommodation for those people that are privileged enough to be able to buy into it.
Speak Tower, what do you think about Ayrton Senna? How did you react when you first learned the project was named after him?
Well, I'm aware. I do follow to some extent the Formula One, and if Senna was a god, and I know here in this country he was revered virtually as a god, and it was a great tragedy when he died under those circumstances. And I think it's really a fitting tribute to an icon of Brazil that this tower will be named after him, and it will have many features which will make people aware of his fantastic career and also some of his human qualities. So I think it's a fitting tribute to a man that was really so well known and so well liked and loved around the world.
You know that the first time when I first heard about the name of Senna involved in this project, probably more than a year or two ago.
Yes.
My reaction was something almost emotional, you know.
Yes.
It was wow, that's a really nice name to.
Yes.
That's.
And I think from speaking from your point of view, the fact that you will be involved in the Senna Tower. I mean, this gives it that extra sort of kudos for your company and your career as compared with, say, the Triumph Tower. And so you can have a Triumph Tower anywhere, but a Senna Tower in Brazil is something that really hits the mark in terms of recognition.
Yeah, we were very happy. We just went there to meet the FG owners and take a look at the apartment and all the videos from Senna family.
Yeah,
that was
it's a remarkable thing. I mean, even though it's a display apartment and it's not the most luxurious one, it would be in the top 0.1% of luxury that I've ever seen, let alone owned. So it's fantastic.
Well, in some months from now, people will be able to see the scale on the scale on steel, and we build after the curtains, and people can see. But that's a 13 meters tall.
Yeah, well, the scale model itself is impressive, but the tower will be incredibly impressive.
Very good. So, bringing our talk to the conference, how has your experience been in the conference, especially seeing so many young engineers approaching you, asking to take pictures and expressing their admiration and gratitude? Well,
to be honest, I mean, it's very good for the ego. I had no idea, and truly, that so many people were aware of me and what I'd done, and it's very gratifying. And I mean, when I was at the university teaching and then in the company that I'm with now, I have been always trying to help the younger engineers to understand and to appreciate some of the things that I've managed to learn, and I've tried to pass those sort of lessons and techniques on, and so I'm absolutely delighted if I'm being able in some direct or indirect way to help the younger generation, because I mean, they're the future of this country and of the world, really, because increasingly we have an international world. You just don't have Brazil or Australia. I mean, you can work anywhere in the world. And,
One thing then, if you feel comfortable to mention this story that you told me, I think some of the students would like to hear that about the SI version of the Lambo Witmans, our mechanics book.
Oh yes, well look, I'm very happy to tell you about that. I spent 2 sabbatical periods at MIT with, and I was working with Professor Lamb, but I also did a little bit of work with Professor Witman. And on my second visit there, they said, we feel as though we need to have an SI edition. Would you be prepared to do it? And I foolishly said, yeah, that would be fine. And I underestimated the amount of effort involved. But it was really a great experience because I was aware of the Lamb and Whitman textbook, but having to convert it into SI, I had to really understand. You just don't change numbers, because somebody had tried that before, but they didn't really understand what it was. You know, when you have something per foot and you change it to something per meter, you've got to change the something and the foot to meters, and so they didn't know this. So it turned out that it was really, it was a big effort, but it was a learning effort on my part, and so I was very pleased to be a part of that conversion, let's say, to SI.
Well, on my master's school, when I went to Federal University of Rio Grande do Sul, that was the textbook from soil mechanics, and that was very nice to see. And I remember that every chapter, I guess, we have several exercises by the end of the chapter. And that's got a lot of work to be converting all of that.
Yes. But anyway, it was, as I say, it was a learning experience, and I was very pleased to be able to be a part of it. And that's still a textbook that is used now, and so remembering that the original version was 1969 and the SI I think was 1979, we're now talking 45 years that the SI version has been around, and so it's good that something of that sort lasts as long as it does.
It's still there, solid concepts, and still use it very well. Well, that's strange. Looking back, what are some of the most memorable experiences you had with your professors, or how did they influence your decision to become a professor yourself?
Yes, look, at the end of my undergraduate career, I had 2 options. One was to become a structural specialist, and the other one to do a PhD in soil mechanics, as it was then. And I chose soil mechanics simply because I had read Terzagh's original textbook. That was my undergraduate textbook. I didn't really understand it, but it seemed intriguing, and structures was very sort of repetitive in some ways, and soil mechanics was mysterious but really fascinating, and so I decided to do the geotechnical soil mechanics option for my PhD, and I worked on the three-dimensional settlement analysis of shallow foundations on clay, and so I did experiments, I did theory, and made some small contribution in that way. And I studied under the late Professor Edward Davis, Ted Davis we used to call him, and he was a big inspiration. I think most people that have gone on to have good careers have had a mentor and somebody that has helped them and encouraged them, and he was that role for me. And so the reason that I became an academic and ultimately a professor was that I got so much enjoyment out of research that I thought I would really like to do this as my career. And so I worked for 1 year as a structural consultant with a company, and then a position came up at the University of Sydney, and I was successful in getting that position. And so I kept on doing research and extended what I'd done for shallow foundations to deep foundations. And I guess that was the start of my career in piles. It started off again with elastic theory, but we of course have extended it beyond that. So,
and then in a moment during your academic career, you started providing also consultancy as an engineer outside of the
Yes, well, I think even when I was a young academic, Professor Davis had a number of consultancy jobs, and I was able to help him on those. There was extension to Sydney Airport, so there was quite a bit of clay consolidation problems that were there, so I helped him in that and did some laboratory testing here and there. And so I sort of did a little bit of consulting work. And what really made my interest in consulting that much greater was when I had my first sabbatical at MIT with Professor Lamb. He had his own consulting company, and many academics in the US did. And he was involved in a number of projects, highway embankment projects, projects in Japan involving the settlement of oil tanks. And so that was something that I was able to get involved in and use some of the things that I had developed in my research. So he was another very influential part of my career, Lamb. And again, when I went back the second time, again I sort of worked on further projects with him, and so I sort of got to learn how you frame reports and so on in a practical consulting way rather than in an academic way, because there are differences, of course, in how you express yourself in an academic paper versus a technical report.
You know that normally if we're talking about geotechnics or mechanics in Brazil, the best universities normally are public universities. And normally, because of law, since professor should be fully dedicated to the university here in Brazil. And so he cannot provide consultancy outside. And that's something that we started to question, because he just keeps inside of the university, not able to go and see different applications in the country, which he could actually help out a lot.
Yes.
And that's something that we still regret.
I think that's an unfortunate policy. I don't want to criticize the country I'm visiting at the moment, but in contrast, I think in the United States certainly, and Canada and many places in Europe, Germany in particular, professors have their own consulting companies, and they still do research, but they apply that research more or less directly. And I think, to me, that's a great benefit, both from the consulting viewpoint and also from the academic viewpoint of teaching, because, I mean, if you are a medical professor, you can't teach without having done surgery. Exactly. Okay, I mean, you have to do that. And I believe, and I know a number of professors in geotechnical engineering that have never been out on a site and done SPT tests and so on. And I mean, this is part and parcel of the practice of geotechnical engineering. And if you haven't had that experience, how can you teach your students, you know, how to apply theory to practice? And to me, that's the biggest challenge. Is the theory is one thing, but realizing that life isn't ideal and you have to then translate the theory into practice, that's really the sort of experience that...
especially in geotechnical terms.
Especially in geotechnical terms. In other areas, structures perhaps, you can get away with doing analysis and so on, because you have other people that do the detailing. But in geotechnical engineering, there's so much judgment that you have to use. Even when you've got a lot of data, you have to use judgment in how to interpret that data for the site. And so I'm very strongly of the opinion that the best academics will be those that have a strong academic background but have also had experience and know how to apply the research to practice. To me, that's one of the big gaps we still have in geotechnical engineering.
That's also my viewpoint, and then I'm proud to say that in our company, all of us, the geotechnical engineers, we all at least have a master's degree, which improves your knowledge in
Absolutely,
geotechnical.
yes.
So we understand that we need to have this background, but we also like to apply it in a daily practice in your life.
Yes.
That's we are very happy to proceed in that way, and also
Good.
stimulate the younger engineers that are working with us now to
Yes.
go there, study, go for their masters and
Yes.
so on. And
Yes.
I think it's something that thinking about asking you. I think you have mentioned to me when I was in Australia with you about since we're in Brazil, Common Seg, about Victor de Mello, which is
Yes.
dear for the Brazilian geotechnicals.
Yes.
And he used to say, correct me if I'm wrong, that he had like the Three Musketeers, right?
Yes.
Can you tell us more about it?
I first met Victor de Mello, I think it was 1972 in Hong Kong at a Southeast Asian conference. And he was, I got to know him there, and he was very supportive in my career. He supported my application for a professor position. And so over the years we got to know each other very well and interacted. And in his later years, he was in the process of writing a textbook, and he was rethinking a lot of the fundamentals of soil mechanics because there were certain aspects that he wasn't happy with. And so he referred some of the questions to Professor John Burland, the late Professor Michele Yamulkowski, and myself. I felt the least of the three, I can assure you, but I was able to sort of try and respond to some of his questions. So he very kindly referred to us as his Three Musketeers, and so it was my honour to really be one of the Musketeers. And my previous visit to Brazil was in Gramado, where I was lucky enough to be asked to give the second de Mello lecture, and John Berlin gave the first, and Yamulkowski gave the third. And so his Three Musketeers, I think, all paid homage to this remarkable person. I mean, he was not only remarkable in terms of his geotechnical knowledge, but also in terms of his intellect and his breadth of knowledge. It was remarkable, and you learn a lot from people like that. So
absolutely.
Yes.
Yeah, that's a very interesting story. I really enjoyed to hear about it. Well, another topic is what do you think has changed the most and the least in geotechnical engineering since you first started your career?
Yeah, that's a tough question. I'll tell you what I think has changed the most, and that is our ability to do computations. When I started off, my university, Sydney University, I started doing research. It had one computer. It had about 1K storage or something. It was a whole room full of valves and so on. And that was the sole computer for the whole university. So I had to do a run each evening. I would go and submit a series of cards or paper tapes and come back the following morning and get the results. And if I'd made a mistake, I'd wasted one day. Okay, so you were very careful about handing in your submission. Now, of course, we jump 60 years or so, and we have remarkable capabilities in this thing that you've got here, in our PCs. I think the pioneers of computing would just be amazed at what you can do now. And of course, it's one thing to have the computer, it's another thing also to have software. When I started, I had to write my own programs in very sort of basic language. Now, of course, we have programs like RS2 and 3 and Plaxis 2 and 3 and Midas and all those sorts of things. And we can do calculations that would blow the minds of people 40 or 50 years ago. What has changed least, I think, is our ability to properly characterize the ground. I mean, we have new tools. We have SPTs we've had for 120 years, but CPTs now, and the various, the seismic CPT, CPTU, pressure meters have developed to a certain extent, And as you know, I'm a great fan of geophysics, and I believe that some of the future, I think, in terms of helping us to characterize the ground is to make more use of measurements of seismic shear wave velocity so that we can get a better understanding of the ground stiffness, because in many projects it's the stiffness that is the critical factor in the settlements and ground movements. And these, on the basis of SPT, it's not very accurate. I mean, you have correlations, and we've developed a whole series of correlations, but the dispersion of correlations is significant. Whereas with shear wave velocity, you have profiles with depth and sort of continuous. It depends a lot on the interpretation of your person doing the test, but once you've got that, it really reflects the in situ performance of the ground profile that you're dealing with. So I think that's something that will, I hope, increasingly be used in our profession.
Well, in our experimental test inside, I was happy enough to take you there to take a look. We will have the results from the surface, the MASW, and then the downhole through the seismic cone, and then the cross also. It will be nice to cross correlate those.
I agree, and as I said, part of the success of doing that will be the proper interpretation of the signals that you take, because that's not something that anybody can do. So you do need specialized abilities to transform those signals into a shear wave velocity profile. But once you've done it, it tells you a lot. It really does.
We're supposed to have fun in the next couple of months if that's those results.
Yes, it will be interesting.
All right. As a globally recognized figure in geotechnical engineering, what advice would you give to young engineers and researchers looking to make their mark in this field?
Possibly two things. One is try and find a mentor that will help you and that can advise you and just assist you both technically and, if necessary, personally, because sometimes I think the personal and the technical side influence each other significantly. And I was lucky to have mentors in Davis and then Lamb. The second thing is to find some area that you feel is of real interest to you, that you feel as though when you wake up in the morning you say, great, you know, I'm going to sort of work in this area, whether it's piles or environmental engineering or something like that. Something that will really grab you and make you feel enthusiastic about the subject. If you're in one way forced to sort of do something that you don't enjoy, I think you need to try and find either somewhere else to go or some other means of being able to use your talents more enthusiastically.
Absolutely. Are there any specific research topics or innovations in geotechnics that you find particularly exciting or promising at the moment, besides or just mentioned the seismic wave velocity?
Yes. Look, when I look back at the history of soil mechanics and geotechnical engineering, there's been a series of bumps, shall I call them, in our knowledge. I think reinforced soil was an early bump in the 1960s in France. Then we had geotechnical earthquake engineering through the work of Seed and people at University of California. Then we had geoenvironmental engineering, which is another sort of step jump. Geosynthetics was another jump, even though it was a more perhaps a different form of ground improvement, but ground improvement generally is another one. And I think we're in the earlier stages of the next jump, which is geotechnical engineering. I think if I was a young academic now, certainly, or doing research, that would be something that would interest me, because it combines and it sort of becomes more scientific, that you combined biology with soil mechanics. And in particular, I think one of the areas that I see as really being important is to use those sorts of techniques, the biological techniques, to do in situ ground improvement. And this is particularly important, I think, in areas where you've had liquefaction, and New Zealand is a case there with their earthquakes about 12 years ago. And you have sites that need to be sort of reinforced and stiffened, and they have buildings on them. And so, you know, a lot of the ground improvement techniques require access to the surface, whereas I think some of the biological treatments you can sort of do by sort of having some form of permeation through the ground that actually stiffens it up. So you've got sort of the precipitation of calcium carbonate, which sort of tends to create cemented soils. You've got, if you're looking at trying to stop liquefaction, you've got little things that cause air bubbles to occur so that you desaturate the soil and so make it less prone to liquefaction. So there's all these sorts of things that now are biological. And the other thing I guess that is biological is that I think there's scope, and it's been done, I'm sure, but perhaps not on a consistent basis. If you have slope stability problems, we have a number of ways of trying to stabilize slopes which require intervention, some sort of insertion of piles or something like that, or drainage measures. But one of the other methods is perhaps to plant trees that are what we call hydrophilic, that will absorb the moisture. And so this is a natural way of reducing the moisture content in slopes and therefore making them more stable. So there's a whole series of these sort of biologically inclined methods that I think are going to be very important in the future. And particularly, I guess, in these days where sustainability is an increasingly important issue, to be able to use those sort of natural biological elements rather than to introduce structural elements and concrete and so on, which are all sort of have a lot of carbon footprint. This is a way that we can actually perhaps reduce the carbon footprint at the same time as improving the ground.
Well, since you mentioned this sustainability issues, thinking about let's say let's go to the tall buildings and that normally have piled foundations. Well, what's your guess? What can we do maybe to improve our techniques as designers, and also all the chain and the contractors and suppliers and all?
Yes.
What you feel about what can we do to be adapting ourselves better to this sustainability issue?
Yeah. Well, the first thing is that we should try and reduce the conservatism that often is present in current foundation designs. And look, there are two competing issues. One, of course, is safety, and the other one is sustainability. And we have to try and find an optimum solution in between those two. The other thing, and it's becoming, I won't say routine, but more common, particularly in places like Europe, is the use of the foundations for energy development, that we can make use of the thermal gradients from the top to the bottom of the piles and have converters that convert that thermal gradient into energy that we can use. And there are a number of buildings now that are in a sense self-sustaining in terms of energy because of the fact that they're using the energy piles in the ground. So it's that's another quite significant development in the last 10-15 years, I think, energy foundations. And I think I showed in my talk the other day that there's scope now for building tall structures, not to house people but to actually generate electricity. And so there's a big future ahead of us, I think, in terms of sustainability. Yeah.
Well, Professor Poulos, that's most of the topics that I have raised in here. Do you have any extra comments, something that you want to discuss?
Well, look, simply to say, apart from the fact that I'm really delighted to be able to be here and very grateful to you and the organising committee for inviting me here, I think the level of geotechnical ability in this country is really very high. And these gatherings, I'm astounded at the number of people that you get to come to these sorts of meetings. I think I have been to international conferences that have far less people than you have here, or you had, I believe, in Sao Paulo, you had even more people there. The other thing that I think is interesting is that you have so many younger people that are here and so many women that are involved. And this, certainly in my country and a lot of other countries, geotechnics is not a common profession that females are inclined to go into. And yet here I see there are so many women here, and I've worked with a number of women in Australia. There are not that many, but they can be remarkably productive and good. You know, they have good brains, and I think it's excellent that in this country you have a much more balanced gender, male to female, than we have perhaps in Australia.
It has changed in the last years.
Yes.
When I went to the undergrad, I started in 2006. My class, we were in 20 students. 2 of them were females at that time. So, and some years later, I seen in the university it started to change. So, so it's good that you have this.
Yeah, I think perhaps as the word gets around about geotechnics, and particularly if you see some of the areas where women are really interested is in environmental engineering, because it's a little more, or it seems a little more scientific and less sort of getting mud on your shoes. And that's part of the problem, I think, that a lot of women think that geotechnics, you'll be out in the field and you'll sort of get dirty and wear hard hats and so on. And that's part of it, of course, but I think increasingly there's a potential for women to be involved perhaps in a more scientific phase, and this biological area, I think, is one that if we can sort of sell that as one of the components of our profession, I think we'll find that there's more attraction for women in that.
You know, that I remember now that we were organizing the conference here.
Yes.
And we started talking about the foundation session and everything, and I became the responsible for that. And I was imagining maybe I could invite Professor Poulos to come here. And then I started typing an email for you. It took me some days to compile all of that ideas and let me really think about what I'm going to say now. Because I understand that Australia is really far away from here. You need it's a long ride to get here, being there, so I know how that. So I sent you an email. It didn't took that much of time for you to reply to me. And you know, the beginning of the year in Brazil, it's in February or March, we have a holiday. It's Carnival for us. So normally it's Saturday, Sunday, Monday, Tuesday, and even Wednesday morning sometimes. And you replied to me during that holiday. I remember I was watching TV, and I got myself inside, and you said that you mentioned a quote from The Godfather that, correct me if I'm wrong, but a proposal like that is too good to be refused.
An offer too good to refuse. I think are the words. Yes.
Then it was some day at night and watching TV. Just saw that, then it made me very happy. Then I just text everyone in the committee on the conference, and everyone started cheering and look at that. And then, so I would like to deeply thank you for accepting being here with us. It's truly an honor to have you in our city.
It's my pleasure to be here, and again, thank you for the invitation.
Well, thank you very much. I think that's it.
That's it. Very good.